Good day students. In this video we are going to learn to calculate the moments about the keel after multiple operations of loading, discharging and shifting of weights on board the ship. So let us consider this cross-section view of the ship. We have the center of gravity of the ship located at the point G, and acting vertically down is the displacement of the vessel denoted by this capital W. You have a weight W1 which is located at G1. Its center of gravity is located at G1 and this weight has been loaded. You have a weight W2 whose center of gravity is located at G2 and this weight is discharged. Then you have a weight W3 whose center of gravity is located at G3 and this weight has been shifted down to this position where the center of gravity is now at G-3, and this weight W4 whose center of gravity is at G4 has been shifted up, whose center of gravity is now located at G-4. To calculate moments about the keel, we have to, in our imagination, turn the ship around by 90 degrees. We are not actually the ship in its real form is not turned 90 degrees, but in our imagination assume that it is possible to turn the ship around by 90 degrees. So we have this ship over here which has been turned around by 90 degrees. The keel, which was at the bottom denoted by the letter K, is now on the side at this point. Weight W1 which was loaded is now assumed to be, in your imagination, loaded along the center line. It was loaded over here, if you remember. Now let us assume that it has been loaded on the center line that is passing through the keel K. Its center of gravity is at G1. The imaginary center of gravity is at G1. W2 was the weight that was discharged from this location. Center of gravity was at G2. But now let us imagine that it was discharged from the center line and its center of gravity is here at this location G2. Sorry. W3 was shifted down from its original position where its center of gravity was at G3 to its new position where its center of gravity was at G-3. So now let us imagine that this weight, instead of it being shifted over here where it was initially as shown in the earlier figure, is shifted along the center line from G3 to G-3. And W4, which was shifted up somewhere along over here, let us assume it is shifted along the center line from G4 to G-4. So now let's go to the next slide. Now we have to take moments. Now moment is weight into distance, W into D. So the displacement of the ship is capital W and the D that we have to take is kg for the ship. So for the ship, the vertical moments are W into kg. For the weight that was loaded, W1, its vertical moments are W1, small w1 into kg1. Okay, the moment we are taking moments about the keel, so it is kg1. This is the D. For the weight that was discharged, its moments will be W2 into kg2. Okay. For the weights that were loaded, the moments are to be added, and for the weight that were discharged, the moments are to be subtracted. for the weights that are loaded, the weights are to be added, and for the weights that are discharged, the weights are to be subtracted. Now we come to the weights that were shifted. W3 was shifted from this location at G3 to G-3. That means it was shifted down towards the keel. When it is shifted down, the moments are to be subtracted. That means now here the D is not with reference to the keel. For shifting of weights, the D is the distance between the original location of the weight, that is at G3, and the new location of the weight, that is at G-3. So the D in this case will be G3 G-3, and the moment will be W3 into G3 G-3, and the moment, as I said earlier, has to be subtracted because it was shifted down. Sorry. Now we come to the weight W4 that was shifted up. It was shifted up from this location G4 to the new position G-4. When a weight is shifted up, its moments are to be added. Therefore, the moment W4 into G4 G-4. Here the D is the distance between the original location of the weight and the new location of the weight, that is G4 G-4. So the moment is W4 into G4 G-4, and this moment has to be added. Let us go to the next slide. As mentioned in my earlier slide, this will produce moments about the keel, W1 into kg1 for the weights loaded, and these moments are positive, and W2 into kg2 for the weights discharged, these are negative. Now for the weights that were shifted down and up, W3 was shifted down, the moment W3 into G3 G-3 is negative, and the weight W4 which was shifted up, the moment W4 into G4 into G-4 is positive. So now we go to the next slide and we see what happens. We make a table. On the right hand side we have a small box in which the sign convention is noted. Weights, loaded weights are positive, discharged weights are negative. Weights shifted, no action, that means they are not added nor they are subtracted, hence they are put within brackets, just as it is shown over here. For the moments for the weights loaded are positive, moments for the weights discharged are negative, moments for the weights shifted downward are negative, and moments for the weights shifted upward are positive. So in this table we have three columns: weights, kg, and vertical moments. W is the displacement of the ship, kg is the distance between the keel and the center of gravity of the ship, and the moments are W into kg. W1 is the weight that was loaded at kg1, and the moments are W1 into kg1. The sign of these moments are positive. W2 was the weight discharged from kg2, and the sign of the moment is negative, and the moment is equal to W2 into kg2. W3 was the weight that was shifted down, and it was shifted down through a distance G3 G-3, and its moment W3 into G3 G-3 is negative since it was shifted down. We have it over here too in this sign convention. W4 is the weight that was shifted up through a distance equal to G4 into G-4, and the moment is W4 into G4 G-4. This moment is positive. We have it here in the sign convention, shifted up, positive. Now after having done these operations, these calculations, we add up all the weights, the sum of all the weights and the sum of all moments. Now that we have found out the sum of all moments and the sum of all weights, we get the final kg to be equal to sum of all moments divided by sum of all weights. This is a much better and an easier way to calculate the final kg of the ship, whether it is by whether it is for multiple operations of loading, discharging and shifting, or even for a single operation. You work out in either way, the answers will be the same. Thank you very much. Have a good day. If you like my video, please give me a thumbs up, share and also subscribe to my channel.